Hi, I'm Marco Perini, one of the co-founder of ScrapeGraphAI. So let me briefly show you the GitHub repo. So here it's where all the library is, and with some information on how to install the library using pip, some demo that we developed for our online hackathon, and the collab link where there are some examples to use it online directly on the notebook using API keys, so not local LLM models, and the documentation that still needs to be updated, and we are currently doing it, and some usage cases on how to use the library using local large language models, using Llama or through the Llama application or Docker, and also using OpenAI models for using an API key and so on. Basically, let's say that I want to scrape my website, Marco Perini, specifically my project section, where there are my project with title, description, and so on. So I just take the URL, copy paste, and let's go to the notebook, collab notebook, to see how the library works. So first of all, we need to pip install the library, pip install ScrapeGraphAI, and insert the API key for OpenAI to use the models such as the GPT 3.5, 4, or also GPT-4 Vision and text-to-speech. And basically how the library works, it works by creating graphs. Graphs is a collection of nodes where each node has its own function. There are three main types of graphs which define some scraping pipeline. The first one is Smart Scraper, the second Search Graph, and then Speech Graph. Here you can see in the picture that Smart Scraper is made of 4 nodes. The first fetch node, parse, RAG, generate answer. So we just input a URL or a local file containing the HTML code plus the user prompt. So what we want to scrape from the website, and we will get a JSON answer. So an answer structured in some way. So let's see how we can do it. We first import the library, my Smart Scraper Graph, which is inside the Graphs module. We define the configuration for the graph. In this case, we use the LLM of OpenAI, so GPT 3.5, and we provide also the OpenAI API key. And this is how we define our Smart Scraper. So we initialize it as Smart Scraper. We just give the prompt, so we want all the project with the description of my website and the source. Here I put the URL, but can also be a local file, a local HTML, so a string. And we pass the graph configuration that we defined earlier. Then we run the scraper using .run, the method. So it will start doing the fetch node, all the different kinds of nodes. So we will retrieve the HTML file, HTML code from the website. We will parse it, split it into chunks, and if the website is really big, and then retrieve the useful information from it, then give this information to an LLM in generate answer node, and what it would do is merge all the info that it finds in the website in a single answer. Then to show the output, we can display the result. Since it's a JSON, we can use json.dumps, and in this fancy way we can see that the LLM understood that he had to create a project key on the dictionary with an array with the title and the description for each of my projects that I've done. So all just by defining a prompt and a source, a URL. Then also we can do it using Gemini. I won't do it now. The second type of graph is a search graph, which is basically smart scraper graph, but with an additional node at the beginning, which search from internet, so it doesn't need to have a URL as input, but just some prompt from the user. It will search on a search engine on internet, return the results, the URL, run smart scraper graph. It will fetch the HTML and do all the previous tasks, and then generate a JSON answer. We can do as before, so we define the graph configuration. We can also define the temperature, which define how much we want the model to be flexible with the answer, let's say. I set it to 0 since we want the exact information found on the website. And then we create a search graph using a prompt, list me all the European countries, and we pass the configuration. If we run this, it will execute the search node, it will modify the search query, it will modify the user prompt to have a good search query. For example, he modified list me all the European countries into European countries list. It will and then it will run smart scraper graph, so fetch node, parse node, rag, and generate the answer. Also, we will display it and see all the European countries, set it like this. So a European countries key on the dict, and an array and a list of the countries. The last graph I want to show you is speech graph. Speech graph is basically a smart scraper graph, but with a text-to-speech node at the end. So it's useful to create summaries of the website. In our case, the configuration will be a little different. We pass the LLM config as before, and then we pass also a TTS module, so text-to-speech model, which in this case only works if the API key is enabled, as has this model enabled, and then an output path where we want our audio file to be saved. We create the speech graph with a prompt, for example, create a summary of the website, the source, and we pass the configuration. So we define it, and we run it. So we run it as before. As you can see, it's really fast, and in return it will execute also text-to-speech node, and we will have audio saved website summary. We will have both the summary, which is this one, and if we run this,
title, projects, Marco Perini, projects, Rotary Pendulum RL, description, open source project aimed at controlling a real-life rotary pendulum.
You can see, yeah, and it will save in the, in our case, in this case, in the collab folder. So website summary, we find it here, and also there's the possibility to create custom graphs. So you combining different nodes as you wish. And by doing this, it's possible to see all the available nodes inside the library. You can get the metadata of the node, and this is an example on how to define a custom graph. So it's a little bit different. We define a graph configuration. We initialize the OpenAI LLM model, which if you use the standard graph pipeline, it's already abstracted, so you don't need to do all these things. And also we define the fetch node, parse node, rag node by defining an input. This input takes, for example, for the fetch node, the key in the state, which is whether URL or local dir, which will fetch the HTML from the local file, and we return as output the output in a doc key. And the same thing as also for the next nodes, rag node, parse node, and generate answer. We use this syntax that basically means find in the state user prompt key, and in the state it must be user prompt and one of these three elements, so relevant chunks or parsed docs or doc, and then return an answer. We create a graph using the base graph class, where we need to input the list of nodes that we want to have in the graph, using fetch node as the first one in order, let's say, and also the edges. So fetch node we connect to parse node to rag node to generate answer, and an entry point. Then we will do graph.execute, and we will have the same result as before, as running the smart scraper. This is basically the smart scraper graph. Okay, I showed you how to do it using OpenAI GPT models, but let's see how we can do it also in local models. So we open our IDE, for example Visual Studio Code. We will import the example that you can find in the example folder for local models, and you open the smart scraper or Llama, which we will use Llama, which hosts LLM models, which we can use to infer some questions. And so in this case we also set the graph configuration. In this case we use LLM, and the model will be Llama / the name of the model, so Llama 3, Llama 3 for example, and JSON, because for Llama we need to also specify the format to be more precise, and the base URL. In this case I'm running Llama on local here, as you can see on the bottom right corner of the screen. So we just input localhost and the port where Llama exposes the model. Then we also need to specify the Embedding model, because if we don't specify this, we will use the same LLM model for embeddings, but it will be pretty slow. So we also specify an embedding model which is way faster. So this is graph configuration, and then the smart scraper graph. As before, we just run and see the results. Good. Now we have the answer with all the projects, and with a list of name, rotary pendulum, description, open source, and this is the answer. By doing also get execution info, we will get the total amount, the time that it took each node to be executed, and some total tokens and prompts tokens, and total cost works only for OpenAI models. If we want to see how much it would have costed to scrape this that information. We can also do the same thing by uploading a file, an HTML file. For example, we will have a plain HTML example.txt which contains a HTML file. We will open it, and this as before, and we pass the text into the source. It will work the same. So that's it for now. I wanted to show you the social network pages where you can find us on Twitter. So we will post sometimes we will post memes, sometimes we will post updates on the library, and we'll try to grow our audience and find some collaborators also and partnerships. We also have a LinkedIn page where you can find us. Also here We have the LangChain posts and all this kind of information you can find it here. And of course, if you want to collaborate, get in contact with us, we have a Discord channel, Discord server with different types of channels where you can, for example, request some features. Here you can see, for example, scrape JSON XML or playwright support for scraping JavaScript-based websites. We have also the support contributors. Here you can see we have already some discussions, and also share your work. Here we can see that test traffic, user library, and develop a front end for it, and showed us the his work, which is really impressive and great. And also about other channels for suggestion and where you can get in contact with us.